All right, guys, we are going to read about Chapter 3, Lesson 6, the rock cycle. So by the time we are done, we are just going to know what exactly is the rock cycle, and you guys will be able to fill in the rock cycle. So we always start out with the My Planet Diary. So rolling along, the Himalayan mountains are eroding at the rate of about 2.5 millimeters per year. They're about 1/10 as fast as your fingernails grow. But the Himalayas were formed millions of years ago. So imagine the total mass of the rock that has fallen down the mountain and that has been swept out to sea. Over millions of years, the piled weight of eroded particles will squeeze the bits together on the ocean floor. New rock will form. Then ancient bits of the Himalayas will be recycled into new rock. So now it asks you to answer the question. So how could small pieces of the Himalayas form new rock? So go ahead and answer that question right here and then move on with us. So what exactly is the rock cycle? So now we're down here at the bottom. So what is the rock cycle? It says natural forces act on the Himalayas. In fact, rock in Earth's crust is always changing. Forces deep inside Earth at the surface produce a slow cycle that builds, destroys, and changes the rocks in the crust. The rock cycle is a series of processes that occur on Earth's surface and in the crust and mantle that slowly change rocks from one kind to another. I want you to highlight that definition. So again, the rock cycle is a series of processes that occur on Earth's surface and in the crust and mantle that slowly change rocks from one kind to another. For example, weathering can break down granite into sediment that later forms sandstone. And by the way, this starts on page 118. I guess I should have started with that. Sorry, guys. On the next page, one pathway through the rock cycle. So this is going to take us one way through the rock cycle. There are many pathways by which rocks move through the rock cycle. For example, Stone Mountain near Atlanta, Georgia is made of granite. The granite in Stone Mountain, shown in Figure 1, formed millions of years ago below Earth's surface as magma cooled. After the granite had formed, the forces of mountain building slowly pushed the granite upward. Then, over millions of years, weathering and erosion began to wear away the granite. Today, particles of granite constantly break off the mountain and become sand. Streams carry the sand to the ocean. What might happen next? So think about it. Think about how sedimentary rocks are made. Weathering and erosion. Think about what happens next. Over millions of years, layers of sand might pile up on the ocean floor. Slowly, the sand will become compacted by its own weight, or perhaps calcite that is dissolved in the ocean would cement the particles together. Over time, quartz that once formed the granite of Stone Mountain could become sandstone, which is sedimentary rock. Sediment that kept piling up on the sandstone. Eventually, pressure would compact the rock's particles until no spaces were left between. Silica, the main ingredient in quartz, would replace the calcite cement. The rock's texture would change from gritty to smooth. Over millions of years, the sandstone would change into metamorphic rock quartzite. So I want you to take a minute and answer the question over here for Figure 1. It says, the granite in Stone Mountain is moving through the rock cycle. Classify. As shown in the photograph, trees can grow on the mountain. Their roots might break up the granite. What step of the rock cycle do the roots play a role in? Number 2. Does the rock cycle stop after the quartzite has formed? Explained. So after this last step, after the sandstone has changed into the metamorphic rock, does it just stay quartzite or does it start over again? What do you think? Explain. So here is a diagram of the rock cycle. It's kind of hard to see and the diagram and the directions. I'm sorry. I'm trying. So how do rocks form? So I'm going to read starting right here. It says, be a rock star. Through melting, weathering and erosion, and heat and pressure, the rock cycle constantly changes rocks from one type into another. Interpret diagrams. It says, study the diagram, then fill in each blank arrow with the correct terms. So I'm going to actually underline these terms for you so you know what they are. So you're either going to use melting, weathering and erosion, or heat and pressure. And it says, hint, to fit your answers, abbreviate weathering and erosion as W and E. Okay, so it says right here, okay, we're going to read the diagram together. I'm going to kind of walk you through it, and you'll have to decide what you're going to use. So let's say we start with an igneous rock. We have weathering and erosion, gives us to our sediment, and then it's going to be deposited. We apply heat and pressure, it turns into a metamorphic rock. And then what do you think is going to happen right here to bring us back to sediment? What do you think we would write here? Figure that out now. What would I do to this rock after I apply the heat and pressure? What can I do to a metamorphic rock in order for it to become sediment again? What would I have to do to it? I'll help you with this one. We would have to use weathering and erosion. Okay, so you would have to write W-E right here. W and E right here. So now we're melting here, volcanic activity, and we're back to an igneous rock, okay? So let's go back to this one here. So I have weathering and erosion, I have sediments that are being deposited together. What do you think I have to do in order to get it to become magma and lava? If I'm here, what do I have to do for this arrow for it to become magma and lava? Write the word right here. If I'm right here, what would I have to do for it to become back to sediments? Write it right here. Now let's go back to our igneous rock. If I'm an igneous rock, what do I have to do in order for it to become magma and lava? Do I have to melt it? Would I weather and erode? Or would I add heat and pressure? And then lastly, if I'm an igneous rock and I want to become a metamorphic rock, what do I need to do? Do I need to melt? Do I need to erode? Or do I need to add heat and pressure? I'm going to write it right here. When you're done with that, move on to this side. Okay. So the rock cycle and plate tectonics. So the changes of the rock cycle are closely related to plate tectonics. Recall that Earth's lithosphere is made up of huge plates. These plates move slowly over Earth's surface as the rest of the convection currents in as a result of the convection current in Earth's mantle. As the plates move, they carry the continents and ocean's floors with them. Plate movements help drive the rock cycle by helping to form magma, the source of igneous rocks. When oceanic plates move apart, magma formed from melted mantle rock moves upward and fills the gap with new igneous rock. Where an oceanic plate is subducted beneath a continental plate, magma forms and rises. The result is a volcano made of igneous rock. A collision of continental plates may push rocks so deep that they melt to form magma, leading to the formation of igneous rock. Okay, I want you to take your pen or your pencil and kind of make an arrow like that and write igneous right here. Because that whole paragraph has to do with igneous rocks. Sedimentary rocks can also result from the plate movement. For example, the collision of continental plates can be strong enough to push up a mountain range. Then weathering and erosion begin. The mountains are worn away. This process leads to the formation of sedimentary rocks. Again, make those little arrows and write sedimentary. That talks about how sedimentary rocks are formed with tectonic plates. Finally, a collision between continental plates can push rocks down deep beneath Earth's surface. Here, heat and pressure can change the rocks into metamorphic rocks. Same things here, but just write metamorphic. And lastly, conservation of material in the rock cycle. Constructive and destructive forces build up and destroy Earth's land masses. But as the rock and Earth's crust move through the rock cycle, material is not lost or gained. I want you to highlight that. Because it's important to know that as everything goes through the rock cycle, nothing is lost, nothing is gained. For example, a mountain can erode to form sediment, all of which can eventually form a new rock. All right, I want you guys to do the apply it. So it says new rock forms from the ocean floor at the mid-Atlantic ridge. Here, two plates move apart. So if two plates are moving apart, is it igneous rock or sedimentary rock being formed at this point A? You have molten material coming up. Okay, and then how can a rock that is formed at the mid-Atlantic ridge be changed into sedimentary? So go ahead and answer those two questions, and when you're done with that, you are done with this section of notes and answering the questions. If you missed anything, pause the video and go back and answer those questions. If you have any questions, you can join the Zoom today from 12 to 12:30. You can email me, you can call me, just let me know. And I hope you guys have a great day and enjoy.